Hello everyone. So in this lecture we will see numerical on correlation. So we have this numerical on based on correlation. A company records the number of defective products in two factories, factory A and factory B, over the last 6 months. So this is the record of last 6 months from July to December, and this is for factory A and this is for factory B. These are the number of defective products. Apply the suitable formula to find the correlation coefficient between the defective products in factory A and factory B. Explain whether there is a strong or weak relationship between the number of defective products in the two factories. So we have multiple methods to find correlation, but in this case we are finding correlation with the help of Karl Pearson coefficient of correlation. So in this case, we will apply Karl Pearson coefficient of correlation, and there are four methods to find Karl Pearson coefficient of correlation. I have already discussed in Karl Pearson coefficient of correlation methods. I will share the link of these correlation coefficient in description. So first method, when deviation taken from arithmetic mean. Second method, when deviation taken from assumed mean. And third method is step deviation method, and fourth method is by using actual data. So first we will check there is constant gap in the term, then you can apply this third one. So in this case there is no constant gap, or we need to find constant gap. We need to arrange this data in order as per factory A or factory B. Then you can find there may be we can apply this SDM method or not. So first, this is arithmetic mean. So if x bar and y bar of the data in integer form, this means without decimal, integer form, then you can apply this first one, and this second formula you can apply in any situation. This is the best one and less time consuming. And this last formula also you can apply in any situation. This is not, we can say this is not as a best, because this is so time consuming. So first task is we will find arithmetic mean for x column and y column. This factory x is considered as factory A is considered as x, factory B is considered as y. So first we will find x bar, and second we will find y bar. So for this first data, when we will find x bar, so this x bar for this case is 7.5, and for this second case is 10.33. So first x bar for this is 10.5, and x bar for this second is 10.33. We will find this x bar and y bar by taking summation of all these x term and divided by 6, and summation of b term divided by 6. Then you can find this x bar and y bar. So in this case, x bar and y bar not in integer form, these are in decimal form. So we will not apply first one. We can apply this first one, you will get the answer, but there may be chances of mistake, or this is so time consuming. So we will apply this second method, assume mean method, and formula for assume mean method is r equals to n summation dx dy minus summation dx, and this is summation dy, and in denominator part there are two under roots. In first under root, term of x and summation dx square minus summation dx whole square, and in second under root, this is n summation dy square minus summation dy whole square. this is summation dy whole square. So we need to find all these things. So first thing is n. What is n? N is number of relationship. So there are 6 pair, that's why n equals to 6. And now you need to find dx and dy. So what is dx and dy? So dx equals to x minus assuming from x series, and dy equals to y minus b, that is assuming from by series. So first we will select a. You can find any value of x as a, but we will take highest plus lowest divided by 2 near about. So highest value is 10, lowest value is 15, total is 15. This divided by 2, so this is 7.5. So we will take value which is near about 7.5. So this methodology is for ease of solution. So near about 7.5 in this data, that is 7. So this is considered as A. Now we will consider corresponding value of y as b always. If you will take any other value of y as b, then you will get wrong answer. So always you will take corresponding value of a as b. So first task is calculation of dx, second task is calculation of dy. Then we will prepare column for dx square and dy square, and we will prepare column for dx dy. So I have already prepared this table. So this first column is for dx is equal to x minus a, and we are taking a equals to 7 and this b equals to 11. So for this first calculation, this x is equal to 5, so this is 5. We will subtract this 7 as a, then you will get minus 2. In second value, this x is equal to 8 and a equals to 7, so 8 minus 7 equals to 1. In that way you can find all these values, and finally in last we will find summation of this column, summation dx is equal to 3. In that way we will find y minus b, that is dx dy. So this first value is 7, b value is 11, so 7 minus 11 equals to minus 4, and 10 minus 11 equals to minus 1. In that way you can find this second column. So summation dy equals to, this is minus 4. Now this is the square of this column, so square of minus 2 is 4. This is the square of this dy column, so square of minus 4 is 16, and this is the product of this dx column and this dy column. So product of this dy and dx, this is this one. So minus 2 into minus 4, that is 8, and then we will find summation. So this summation is summation dx square, this summation is summation dy square, and this summation is summation dx into dy. Now we will put in formula. So this is the formula. I am copying this formula. So we will put all these values in this formula. So this is r equals to, so for this case r n equals to 6, and summation dx into dy, this summation dx into dy is this 17 minus, this is summation dx and summation dy. So for this summation dx and dy, these are 3 and minus 4. So this is 3 and this term is minus 4. Now 2 under roots, one is for x, second is for y, and this is n. So for n equals to 6 in both. This is also n. Now this is summation dx square. So this second value is summation dx square, this value is summation dy square. So summation dx square is equal to 19, and this summation dy square is equal to 26. And minus This is summation dx whole square. So summation dx is equal to 3. So that's why we will write square of 3. And this is summation dy square. So summation dy is minus 4. So we will put minus and minus 4 square. And on solving this, you will see this 102 minus. This minus minus become plus. And this is 140 minus 9 and its under root, and this second term is to 156 minus 16. So on solving this, you will see the value of correlation is plus 0.94. So now we will interpret this is strong or weak correlation. So as the value of correlation lies between minus 1 to plus 1. The value of correlation lies between minus 1 to plus 1. So if the value is exactly 0, r equals to 0, then there is no correlation. And if the value is, this is 0.5 negative, this is 0. Plus 0.5. So if the value lies in this region, in this middle region, so this is the reason for weak. This is the weak region. And if this value lies in this region, then this is considered as a strong region towards 0. So now we will check our value. So our value is 0.94. So 0.94 lies at this location. This is the location for plus 0.94. And this is the strong region. And this is positive value. So we can say there is positive, strong, positive correlation between defects of factory A and B. Factory A and B. So this is the solution of this question. So I hope you understand this concept. So please like this video and subscribe my channel, Ganit Coach. Have a nice day. Thank you.